Welcome OnShape users, students, YouTubers, whatever's out there watching this. You've got hearing and eyesight. You're lucky. You're an amazing individual. You're healthy enough to perform this task. Good for you. Let's get down to it. This video is going to cover the dimensioning of the block you're looking at right now. So there are a couple prior videos that show you how to make this. Video one is from I'm going to steal some terminology I saw from comment section on another YouTuber's channel, is I guess a more rendering approach, meaning you were just creating the physical representation of the object. But the second video covers what if you are doing it from a design approach, and that means how easy is it to go back in and edit changes if you need to scale the design up, if you need to scale the design down. A lot of design has relationships established as far as bolt patterns go, or certain things go, that when you go back to change them, if you go about the process correctly, you'll be able to just change things very, very quickly. So you'll have to go back and watch those videos. It's very, very hard for me to describe this. Honestly, I don't come straight from industry doing this. I ask and talk to a lot of people doing this. I've done most of my CAD work through the educational setting, some professional, but not very many. And so it's hard for me to describe. You'd have to go back and watch those. And if you are from industry, please troll me up if you need to. Again, these videos are going out to students, and I find it very important to get the most authentic information into their hands. So let's get straight down to dimensioning this project. And the way you're going to do that, I've made this public. So if you want to, I'll put a link in the video and you can download this if you need to. If you're one of my students, you've got this. You should be done with this. And so I've got my screencastify tools in the way again. Pull this file up. If for some reason the numbers are different because of another activity we've done where we've either scaled it up or down, don't worry about it. The main point of this video is not that your numbers match my numbers, but your practices match my practices for dimensioning. Because when we create a dimension, a plan, a print, which is what you're about to do for this part, remember that print should be able to go to a non-English speaker. That non-English speaker, if they've got any print reading experience, will be able to take that print and fabricate their part. And that's why some people argue that drafting can substitute as a foreign language in some academic institutions. So the quickest way to make part drawings, right click and select create drawing of part one. And the nice thing about doing it through this way is you can select 4 views and it will automatically give you those 4 views. And now I'm in the way. Get out of the way, Barbercheck. All right, once this video comes up, once this plan comes up, what we're going to do is change one of the views. We're going to include all the dimensions we need to include, and then you're going to be set on dimensioning. So let's speed things along. First thing I want to do is I want to turn on the hidden lines on this view. And so what that should look like is just right click, select show hidden lines, and then now you have these hidden lines. Just by looking at it, you should be able to conclude what hidden lines are. That's weird. Oh, it said hide hidden lines because I had 2 of them selected. So you could, I think, select all of these at once. I must have show hidden lines blocked again. There we go. And then just do this all at once. I suppose that would make sense. Now this one, I'm not going to click show hidden lines because what I'm going to do instead is delete this view. And I'm going to add a section view. So this button right here, section view, you can pick what orientation you want your view to be broken in. And if you did our donut dimensioning video, then you know that what we're doing is essentially cutting this part in half. So pretend that this is a saw blade. Bzz, cut that in half, and the view we get is the same as the top view, only now, follow my mouse here, we get this top view looking straight down through the middle of that hole. And so that will make dimensioning the location, this arc, a little bit easier. All right, so it's a basic block. We definitely know we need length, width, and thickness. Let's add that in. We're going to do our length. And as a general rule of thumb, I was taught you want to be about about 3 letter heights away at least. All right, so 4. Now, this is a square, right? I can come over here and dimension this, and I've got my length and my width. Here's something we're going to do to save time and to imply that this part will always be a square for one reason or another. Just put 2x right there, and that tells you that the feature that's similar to that 4 is going to be 4 as well. So the width, which is a feature that's very similar to the length, the exact same in this case, is going to be also 4. So we got our length, our width. Now all we need is our thickness or height, depending on how you think about it or how you're picturing things. And I'm going to go ahead and just, whoopsies, not use my section view because we already did that. And actually, this gets a little crowded to that guy right here. So I'm gonna go ahead and come over here because I know I'm gonna have to locate the hole and dimension it like so. All right, speaking of locating this hole, all right, what we're going to do is just like plotting a point on a graph in your math class. You've got your X and your Y, and you've got your coordinates of parentheses 3, 2, knowing that means you go over 3 and up 2. We need to provide that same information to our fabricator, our machinist, our maker, our doer, whoever is putting this together. And so before I do that, I'm going to add a center mark to these holes. All right, and then we're going to give them just pretty much what would be an XY coordinate for locating these holes. So right here, we know we're 1 inch away. And then we're going to go from here to here, and that we're 2 inches away. Now, this one was a little tricky for me to kind of figure out just exactly what information we needed because of the arc and everything else. So again, if this is viewing this from an industry perspective, please offer your input. However, I have concluded that we should be able to just do an edge-to-edge center line from here to here to tell us that this is, we're going to drag that center line past the edge of the part, because typically center lines do that. We're going to give it a radius. Oopsies. All right, and then the only other thing we need, well, there's a couple things we need, but I'm going to go ahead and do this right here to cover my next talking point. I'm including the diameter. All right, so now if we know the radius of this arc, this middle arc, by default, if we know the radius of this arc and the diameter of this circle, by default, we can figure out real easily what the distance is to what the inner radius is and what the outer radius is. With those two pieces of information, we get the same information. And then we're going to go ahead and locate this hole. And the reason I'm going to go ahead and locate this hole on this face is because we don't know how much of an arc this is. I guess in theory it could be, it looks like a perfect 90-degree arc, but maybe it's a 95-degree arc, maybe it's a 98-degree arc. Either way, it would slightly change the location of its exit if that was the case. So as best as I can tell, if I locate this hole, have this radius, and have the start hole located, it should tell me exactly what I need to know to fabricate that part. I can't think of any information that I'm missing. So I'm going to go ahead and do that. And then once you have this, remember you're just doing X and Y. So we're going to do our 1. Quick tip, never put a smaller dimension above a bigger dimension. You always kind of want to ladder down and not crowd too much. And then we're going to do the same here. And there we go. That should give us all the dimensions that we're doing. So there it is. The second video on dimensioning the beehive tunnel is what we called it in the first video. And if you've got an industrial application for this, I was thinking coolant passageway, maybe. Please let us know. If not, hope you enjoyed it. We'll be back with more.